In this video, we're going to write the equation of a hyperbola centered at the origin in standard form. And they say write an equation for the hyperbola that has vertices plus and minus 3, 0, and foci plus and minus 3 root 5, 0. So I want to do a quick graph of this to see what it looks like. So if I graph 3, 0, that'd be 1, 2, 3, and negative 3, 0, 1, 2, 3. This would give me, so we would have a hyperbola on this side that looks like so, a hyperbola on this side that looks like this, and the transverse line would be right here. So we are opening left and opening right. Now I have some information written down about which type of equation we need when we're opening left and right. So when we open left and right, it's always x squared over a squared minus y squared over b squared. And if it's opening up and down, then it's the x squared and y squared are flopped. So we're going to be using x squared minus y squared over a squared and b squared is equal to 1. So we already know a right here is 3 because the vertices, the distance between the vertex or the vertices and the center is always a. And then this is c because this is the foci. So we can go ahead and find a squared. So a squared is equal to 3 squared, which is 9. And then we can find c squared. C squared is equal to, we're going to say 3 root 5 squared, which would be 9 times 5, which is 45. And so then we can use this equation, c squared is equal to a squared plus b squared for hyperbolas. And we can say that 45, which is c squared, is equal to 9, which is a squared, plus b squared. Let's subtract the 9 on each piece. We end up with 36 is equal to b squared. So our equation is going to be x squared over 9 minus y squared over 36 is equal to 1. And this would be the equation for our hyperbola.